Today we're going to use our 6-step process to do a hypothesis test for a proportion. So let's jump right into an example. So a soft drink maker claims that a majority of adults prefer its leading beverage over that of its main competitors. To test this claim, 500 randomly selected people were given the two beverages in random order to taste. So there's our sample size. We're asking 500 people. Among them, 270 preferred the soft drink maker's brand, 211 preferred the competitor's brand, and 19 couldn't make up their minds. So we're going to lump the 211 and the 19 all together because we're just looking for people that prefer this particular drink. And let's see, where were we? Determine whether there is sufficient evidence at the 5% level. So I'm going to start writing out some of the things I've got here. To support the soft drink maker's claim against the default that the population is evenly split in its preference. So you've got a sample size of 500, 270 are the number of successes or people who chose this drink maker's brand, and we're using a significance level of 0.05. So in this first step, I'm just kind of identifying all my information, making sure I have each number with the right variable. And I'm going to do some of the basic calculations that I know I'm going to need in later formulas. For instance, I need the sample proportion of people that chose this soft drink. And so that's x over n, or 270 over 500. I'm going to call that p hat. So that's my sample proportion. I also need a population proportion, and that's going to be my p. I'm going to use that writing my hypothesis statements. And also Q, which is the complement of P. So P, so if we think about what the claim is that majority of adults prefer this beverage, so more than half would be a majority. So I'm going to say that P is 0.5, that's worst case scenario that exactly half do, and so Q is also going to be 1/2. And so this is what I'm going to use, that P equals 1/2, in my hypothesis statements. The null hypothesis, H naught, is always P equals a value for proportion. And then their claim is that it's actually bigger than 0.5. And so that's going to be my alternative hypothesis. P is greater than 0.5. And that is my claim. So I'm just going to give myself a little note there that this is in fact the claim, and that's going to help me in that last step to determine whether we are supporting that claim or failing to support or rejecting, that kind of thing. I'm also going to note here that because my alternative hypothesis has a greater than symbol in it, this is going to be a right-tailed test. So when I get to that distribution, I'm going to look at the value to the right of my z-score. Okay, on to step 3. So I always want to identify what test am I doing and what are the requirements for that test to make sure that the situation does meet those requirements. So this is a proportion. We get to use a standard normal distribution, and so I'm going to call that a z-test for a proportion. And whenever we're doing this test, we need to make sure that the sample size times the population proportion is at least 5, and same thing for n times the complement of the proportion. So if I check those and I plugged in my p hat and q hat instead, those should both be 0.5, not 0.54 and 0.46. Either way though, we're going to be well over the minimum of 5, and so we're going to be able to still do this test. Okay, so now that we know we can do the test, let's find that standardized test statistic. So this is the formula for finding z for hypothesis test for proportion. And I did find all of those values, identified them all in that first step, so I can just take those and plug them in to the formula. And be careful to make sure that you put the P and the Q in there, just like I did in step 3. You're going to want to use P hat and Q hat because that's what you did when you were doing confidence intervals, but here it's P and Q. So if I plug all that into my calculator, I get a z-score like this. And if you're wondering how in the world do I plug that into my calculator, well, let's take a look at that. So I'm going to do parentheses to ensure that the subtraction happens first before the division on this. And so that was 0.54 minus 0.5. Close off the parentheses so they subtract, and then divide by the square root. So second square root of p times p is also 0.5, divided by a sample size of 500. And there we go. I get about 1.789. So back over here, that means that I have a value somewhere around right here is where my z-score is on my standard normal curve. And because we said this was a right-tailed test, I am using the area to the right. That area right there is going to be my p-value. And so that takes us right into the next step. We're getting close to the end here. Is calculating that p-value. And so I'm going to show you how to do this on a calculator and in Excel. So either way that you're doing it, it's going to work. So if I'm using it in a calculator, I'm going to use the normal CDF function. So let's do that. Okay, so we're going to go second distribution to get to our list of distributions. And number 2 on this list is the normal CDF. And so that right tail means that we were starting at our p-value, z-score, which was 1.789. And then I'm just going to go to some ridiculously large number as the upper limit. So say 10,000 is definitely way out of the ballpark. This is the standard normal curve, so the mean is 0 and the standard deviation is 1. And then I'm going to paste. And then just hit enter one more time for it to calculate. And we get a p-value of 0.0368. And let's see, yep, that's what we got. And it's less than 0.05, which was our alpha, our level of significance. And so it's going to help us in that final step to make a decision on whether to reject H0 or not. Before we do that, though, let's see how this works in Excel. In the calculator, I was able to choose a lower and upper limit. In Excel, you don't have that option. It always calculates the area to the left of whatever value you plug in. And so in order to get a right tail, I'm going to have to do 1 minus that value. So let's flip over to Excel. I've got everything set up in here. I calculated my z-score by calling the cells up here. And now for the p-value, I'm going to start with 1 minus, and then norm.dist. The x value is the z-score I calculated. And then the mean. And the mean is 0, again, because this is a standard normal curve. Standard deviation is 1. And I'm always going to go true because I want that cumulative distribution. Okay, and if I hit enter, I should get the same value. And we did, about 0.0368. Now you might have noticed on that list that there is a norm.s.dist. This one, when you get really comfortable with Excel, is great because you're telling it that S is standard normal, and so it already knows what the mean and standard deviation are. So you don't have to type it in again, which is kind of nice. It does save you a little bit of time, and so I can just give it the z-score, choose true, and I get the same value, just a little bit faster. And sometimes you kind of get thrown off on these, trying to remember, wait, what's the mean? I don't see a mean on there. So that kind of helps with that kind of thing. Okay, so we got our p-value. We've noticed that it is less than 0.05. And so that just means we're going to go to make our decision about H0 and then about the claim itself. So when the p-value is less than alpha, I reject H0. And then we have to remember, okay, H0 was not the claim. In this case, the alternative hypothesis was the claim. So I skip over this first column and go straight over here. There is enough evidence to support the claim, okay, because we rejected H0, so we can support the claim. And so I've just put together that final statement, give it some context back to our drink problem. So there is enough evidence to support the claim, the maker's claim, that a majority of adults prefer its leading beverage over that of its main competitors. And there we have it. We have completed a hypothesis test for a proportion.